Good morning, my dear students. Today we are discussing another important topics in 10th physics, that is heating effect of electrical current. The heat is developed in a circuit on passing a current through it. This is a very important point. Heat is developed in a circuit on passing a current through it. Okay. So in this video we are discussing the heating effect of electrical current. Okay. The first point, we already know the electricity is the most widely used form of an energy. We cannot see electricity, but we can see its effect. Basically there are four important effects of electrical current. The first one is heating effect. Second one is the luminance effect. Luminance effect is the lighting effect. Third one is the chemical effect. Chemical effect means it's a battery charging and discharging is an example of a chemical effect. The fourth one is the magnetic effect. In these four effects, we are very important in only two, that is heating effect and the magnetic effect. Okay. So in this video we are discussing about the heating effect of electrical current. So it's a very important terms. That is Joule's law. Actually, Joule is a scientist. According to Joule's law, the heat generated in a current carrying conductor, is directly proportional to the product means the multiplication of the product of the square of the current. The square of the current, that is I square. The square of the current in the conductor and the heat is directly proportional to the resistance of the conductor, that is capital letter R, and the time of flow of current, represented by letter T. Means, according to Joule's law, the heat developed in a conductor is directly proportional to the square of the current and directly proportional to the resistance and directly proportional to the time of flow of current. So according to, I can represent an H proportional to I square R into T. Right? How we can eliminate the proportionality constant? So we can replace the proportionality with an equal. We can add a constant. Here I am put the constant is equal to 1. Then I get H is equal to I square R into T. It's a very important. So H is equal to I square RT. Right? See, equation wise, the factors on which the Joule's law of heating is depends. There are three factors. First one is current and the square of the current. How? The heat is directly proportional to the square of the current and the resistance directly proportional to the resistance and the time H proportional to T. So H proportional to I square, H proportional to R, H proportional to T. So I am combining these, I get H proportional to I square RT. So H is equal to I square RT. Clear? Okay. So next, here I am using a table. The analysis the table and find out the factors that influencing the heat. First one, here there are 5 tables. First one is the resistance of the conductor. Second one is the current, how much amount of current flows in the conductor. Next one is the time, that is represented by T, time in second, current is in ampere, resistance are in ohm. The fourth column is the heat generated, H is equal to I square RT. What is the unit of heat? It is joule. Okay, represented by capital letter J, joule. So H is equal to I square RT. Okay, the next one is the change in heat, H. First one is the heat H, means H is equal to I square RT, right? Okay, first table. The resistance is 2R. A conductor having a resistance is 2R and the current is I and the time is T. What is the heat? heat is equal to I square into R. Instead of R is equal to 2R into T. That is equal to 2 times I square RT. I square RT is H. So this is equal to 2H. So twice the heat. And the resistance is R and the current is doubled. Current is 2I and the time is T. Then what about the heat? Heat is equal to 4I square RT. That is equal to 4 times the heat. Here the resistance is half, current is I and time T. Then the heat is equal to I square RT divided by 2. Means the heat is half. Next one is R. Resistance is R and the current is half, I by 2 and the time T. So heat is equal to 1 by 4th into H by 4. Means the heat is 1 by 4th. Okay. This is a analysis table. Clear? Okay. Next. Some other equation for Joule's law. We already get H is equal to I square RT. Right? According to Ohm's law, we can represent I is equal to V divided by R. Right? According to Ohm's law, I is equal to V divided by R. I am substituting this I into H is equal to I square RT. So my equation become H is equal to V divided by R all square into R into T. So that is equal to V square by R square into R into T. R square and R will be cancelled. So finally I get H is equal to V square by R into T. It is another equation for heat. H is equal to V square by R into T. Okay. Next. And another equation. We know H is equal to I square RT. According to Ohm's law, R is equal to V by I. I am substituting this R into this equation. I get H is equal to I square into, instead of R, V by I into T. I square and I will be cancelled. So finally I get H is equal to VIT. So these are another equation for heat. So finally I get there are 3 equations for heat. First one is H is equal to I square RT. Second one is H is equal to VIT. Third one is equal to V square by R into T. Okay. Yes. Next. Actually it is a problem. You just check. The details of 2 electrical heaters are given below. How much will be the heat developed if they are made to work for 5 minutes each? Here there are 2 heaters, heater A and heater B, and its working voltage is equal to 230 volt, 230 volt. Both are working with the same supply, and the resistance of each heater is, the first heater is equal to 1150 ohm, second one is equal to 460 ohm. So heater B have less resistance. Working time is 5 minutes. I am finding the heat. H is equal to V square by R into T. So the first heater H is equal to 230 square into time 5 minutes. You just convert it into seconds. We will get 300 seconds divided by resistance is equal to 1150 ohm. So we will get 13800 joule. In the same way, the second heater B, H is equal to V square divided by R into T. So 230 square into 300 divided by 460 is the resistance. Then we will get a heat of 34500 joule. Right, means the heater B have more heat. Why? Because the heater B has less resistance. Less resistance means more current. So heat is proportional to the square of the current. Right? So second heater has less resistance. So more current will flow. So the heat developed is high. Clear? Okay. The next, the heating effect of electricity is used. Some of an electrical equipment we are used for the heating effect. First one is an iron box, soldering iron, electrical heater, induction cooker, like the device. The electrical heating appliances are the devices which are used to convert an electrical energy into heat. In such instruments, the heat is produced in the heating coil. Here the heating coil is made up of nichrome. It's a very important term. Nichrome. The heating coil used in the nichrome. Actually, the nichrome is an alloy of nickel, chromium and iron. Nickel, chromium, iron. The alloy of nickel, chromium, iron. That is nichrome. The importance of the nichrome heating coil. Nichrome has high resistivity and high melting point. That's a very important point. High resistivity and high melting point. And the nichrome has an ability to remain in the red hot condition for a long time without getting oxidized. It's a very important point. First one is a high resistivity, high melting point, and the ability to remain in the red hot condition for a long time without getting oxidized. Clear? Okay. So thank you so much for watching this video. Thank you.